All right, so we are in section 3.2, and we're going to talk about parallel lines and transversals. So this is really all this information should, the first part at least, should fit on your graphic organizer that we started on block day. And we have a lot of the first part is we're just going to be filling in the blocks on that graphic organizer. So first off, I need to talk about how we show, or what kind of symbols we use to show that lines are parallel. So we know that we use the little tick marks to show that things are congruent. For things that are parallel, we use arrows. So if we have these two lines and we're saying that those are parallel, I would put little arrows on the line. So the arrows mean that the lines are parallel. And if we have more than one set of lines, we could then use a different number of arrows. So on these I could put 2 arrows, and that means that those two lines are parallel. These two are parallel to each other, and these two are parallel. So basically, like our tick marks, the lines with the same number of arrows would all be parallel. So
does it matter which way they go?
No. Usually they go left to right, but it doesn't have to. So any line that I drew that had 3 arrows on it would be parallel to these two lines. So the arrows show that our lines are parallel. And our symbol to show that lines are parallel, if I call this line A and this line B, we say that A is parallel to B. So the two lines together mean is parallel. So anytime we write those two lines, that means the two things are parallel. So those are our little bit of symbols. So any questions on those? And we'll use this shorthand for parallel. We'll use this quite a bit. All right, so the next bit of information is going to go on your graphic organizer. So on block day, we named our different angles. We named the corresponding angles. We named the alternate interior, alternate exterior, etc. Now we're going to tell what special things happen when our two lines are parallel. So let's start with I'm going to start with the box on the bottom left, the same side interior or consecutive interior. The bottom left box, it says same side interior or consecutive interior. So now what we're saying is that the two lines on our graphic organizer are parallel, and they're being cut by a transversal. We have two parallel lines cut by a transversal. We know which angles are same side interior. We've labeled those before. That's 3 and 8 and 2 and 5. When the two lines are parallel, same side interior angles are, and that's the blank on the bottom there, are supplementary. And we're going to use this as our postulate about parallel lines. So you might want to put in that box or underneath there that this is our postulate about parallel lines in the transversal. And what does postulate mean again? We accept it as true without proof. So we're accepting that when two lines are parallel and they're cut by a transversal, that same side interior angles are supplementary. And supplementary means their measures add up to 180. Just if you need to write that reminder in or on the side or something. So that's a nice property of parallel lines. When we have two parallel lines cut by a transversal, those same side interior angles add up to 180 degrees. All right. Now we'll start in the top right with our alternate interior angles. So our alternate interior angles are the angles between the parallel lines. That's our interior. And on opposite sides of the transversal, that's the alternate part. So just looking at the picture, what would you guess is true about alternate interior angles? About angle 2 and 8 and angle 3 and 5. What would you guess is true about those? Anybody have a guess? A conjecture? So we have one person that says they're the same, one person that says supplementary. Both good guesses. It turns out, and we approve either of alternate interior or alternate exterior. They're really the same thing. It turns out that alternate interior angles, when we have parallel lines, are congruent. So on your picture, angle 2 and 8 would be congruent, and angles 3 and 5 would be congruent. So all those pairs of alternate interior angles that we listed, those two pairs, would be congruent angles. So another interesting thing that happens when two lines are parallel. Okay, so let's go to the top middle, corresponding angles. So corresponding angles, we listed our corresponding angles, and the hint that I gave us about corresponding angles is they're the angle pair where one is on the interior and one's on the exterior, and they're both going to be on the same side of the transversal. Corresponding angles are the ones that students find more confusing than others. Corresponding angles, when we have two parallel lines cut by a transversal, are congruent. So all those pairs of corresponding angles that we listed, they would be congruent to each other. Then we'll use this to figure some things out about parallel lines, about different shapes. Now to the top right, alternate exterior. So from what we said about alternate interior angles, what would you guess about alternate exterior angles? They are also congruent. So angle 1 would be congruent to angle 7 on your diagram. Angle 4 would be congruent to angle 6. So when we have two parallel lines, our alternate exterior angles are congruent. And then finally, on the bottom right, same side exterior or consecutive exterior. So based on what we have said so far, what would you guess about those pairs of angles? They are supplementary. So our alternate angles, alternate interior, alternate exterior, congruent. Our same side angles, interior and exterior, are supplementary. And then our corresponding angles are also congruent. I'm just going to flip back here really quickly. So this first one we're using as our postulate for this section, the same side interior angles. All the rest, if we use this as our postulate, if we accept this first one as true, we can prove all the rest based on this postulate. And we'll do one proof in just a minute, proving one of these. So all the rest of these are theorems. So this first one is a postulate about our same side interior angles, and the rest are theorems that we can prove using our postulate. All right, so we have the names of all these angle pairs. Now we know when the lines are parallel, when our two lines are parallel and they're cut by a transversal, we know all kinds of things that happen then. So let's take a look at a couple of examples of how we can figure some things out using this new bit of information when we know that the lines are parallel. So any questions before we go on? Okay. So for this example, I'm going to draw a picture, and we're going to label our angles. I'm going to make my lines here. And I'm going to say that these lines are parallel. So to show that they're parallel, I'm going to put these little arrows on. So those two lines are parallel. Now I'm going to cut the two parallel lines by a transversal, like so. And I'm going to label these angles. 1, 2, 5, 6, 3, 4, 8, and this one's 130 degrees. And the question is, which other angles measure 130 degrees? So we want to pick out the other angles that measure 130 degrees. So who can help me out with one?
4.
Angle 4. Angle 4 is measure of angle 4 is 130 degrees. And why do we know that one's 130 degrees? And what did we give what name did we give when angles were situated that way? It's on the very bottom of your sheet.
Vertical.
Vertical, very nice. These are vertical angles. And did someone else have one? Same? Angle 2 is 130 degrees. And why is that one 130? So one is interior, one is exterior, so we call those corresponding. So it corresponds to angle 4. And another way we could say that is it's also an alternate interior angle with the 130 degree angle. So there's two different ways that we could say it. So this is corresponding to angle 4. Or it's alternate interior with the 130 degrees. And then Sam also said that measure of angle 5 is 130 degrees. And we could have several reasons for that. These two are vertical angles. These two are corresponding angles. And these two are alternate exterior angles. So we have several reasons that we could use to say that those angles are 130 degrees. Yes? Yes, so angle 2 would be alternate interior. What Sam said was if we know angle 4 is 130, then 2 is a corresponding angle to angle 4. So we could say it that either way. Either way would be the right way to say it. So we have several reasons that we can use. And that's another nice thing about parallel lines is we have all of these different relationships that we can take advantage of. So we can figure out all kinds of angles. One really cool thing about parallel lines, just looking at this, can't we figure out all the rest of these angles? Because what do these two have to add up to? 180. So I can figure out this one, angle 8 would be what? 50. And that means this one has to be 50. And that one has to be 50. And that one has to be 50. So we can figure out all the rest of those angles. And they're all, each one is either 130 or 50 for that one. So we just have two angles. We just have to figure out where they go. Okay, questions on that example? All right. Let's do one more example, and then we'll prove one of those theorems about the angles in the parallel lines. So I'm going to draw this diagram's a little more complicated, but not too bad. And for this diagram, we're saying that, and I'll mark it in red so we can see it, those two lines are parallel. And I'm going to say that this angle is 50 degrees. And this angle is 60 degrees, and this angle is y. And we want to find y. So there are a couple of ways that I thought of doing this. Does anybody have any ideas? Sometimes okay, so Faye says let's add 60 and 50 and y, and that would have to equal 180. So are you saying that this angle here is 50 also? Okay, so we can do that. So we're saying, so Faye is saying this angle is 50 degrees. Why is that angle 50 degrees? Interior, and they're alternate. So these are the parallel lines. This is my transversal. So these two are alternate interior angles. So we can say that this angle here has to be 50 degrees. And because this is a straight line, we know that y plus 60 plus 50 has to equal 180. They make a straight line. So we say y plus, what is it, 111? Or sorry, 110 equals 180. Add those two together. Subtract 110, and y equals 70 degrees. Anybody see another way? Another way to do it? There was one other way that I thought of. What about these angles in here? What do all the angles inside a triangle have to add up to? $180. So all three of these angles have to add up to 180. So this is 50 plus 60 is 110. They all add up to 180. So what does that make this angle? That makes that 70 degrees. And what kind of angle are these two? For this transversal, those are also alternate interior angles. So we could figure it out that way as well. So that's two ways that I thought of figuring it out. There might be some more. But that's the first. I think phase one was the first one I thought of. And that's a good one. And then I also thought of a triangle. So sometimes with problems like this, it's helpful just to say, okay, what can I figure out? Well, I know what these angles are, and you start writing angles, and eventually you figure out your answer. Questions on that example? Okay. So let's do one proof today, and then we'll be done. So let me draw a picture. We're going to prove one of our theorems about our parallel lines. And we're saying that these two lines are parallel. And I'm going to label this angle 1, angle 3, and angle 2. And we're given, this is line A, and this is line B. So we're given A is parallel to B, and we want to prove that angle 1 and angle 3, I guess this isn't one of our theorems, but it's kind of related. Prove that angle 1 and angle 3 are supplementary. So we don't have a special name for those two kinds of angles, or we're going to prove that they're supplementary. So let me sketch out how we're going to do our proof. What do we know about angle 1 and angle 2? Are they inside or outside the parallel lines? 1 and 2. Outside, so they are exterior angles. Are they on the same side or opposite sides of the transversal? Opposite, so what kind of angles do we call them? Alternate exterior angles. The lines are parallel, so what do we know about alternate exterior angles? What did we say on our graphic organizer? They're congruent. These two are congruent. What do we know about these two? They are at 180. They are supplementary. So if these two are congruent and these two are supplementary, then those two have to be supplementary, because angle 1 and angle 2 have the same measure. They're congruent. That's the sketch, the outline of our proof. So let's write our statement. Not proof, our reasons. So let's start with our given. Line A is parallel to line B. So we know that's true. And we've already talked about this. I'm going to say that angle 1 is congruent to angle 2. And we said the reason, all we have to do for our reason is say that they are alternate exterior angles. And now I'm going to say that the measure of angle 2 plus the measure of angle 3 equals 180. And what's our reason for that? What kind of angles do we call these two? Two angles that make up a line. They're supplementary. We gave a special name for those two kinds of angles. A linear pair. And I'm going to put in parentheses out here, we could say it, I'm not going to write it out here, that the measure of angle 1 equals the measure of angle 2. If they're congruent, then their measures are equal. That's the definition of congruent, but I'm just going to write it in there. So now, what I'm going to do is I'm going to take, since measure of angle 1 and measure of angle 2 are the same, I'm going to take this and put it right there. Since those two are the same thing, same number, now I'm going to say the measure of angle 1 plus the measure of angle 3 equals 180. And what would be my reason there? Transitive, angle 1 is, yeah, we can say transitive. I was thinking, what did I do with measure of angle 1 here? What do we call it when we stick it in there? Substitution. So we transitive would work. I was thinking substitution. And now we can say that angle 1 and angle 3 are supplementary. And what would be our reason there? What does supplementary mean? They add up to 180. So this is the definition of supplementary. That's what it means for them to be supplementary, is that their measures add to 180. So there's our proof. We proved that that angle 1 and angle 3 are supplementary. They add up to 180. So not too bad. And what I want to do with proofs is just, we'll look at them here and there and get a little more familiar with them as we go on throughout the year. So questions about parallel lines, transversals? Okay, so all of our homework tonight involves figuring out things when we have parallel lines, figuring out what angles are congruent, what angles, so figuring out the measures of angles using the information that we put on that graphic organizer. So let me, we'll pass out the folders, and I will